Welcome. Let us discuss about recursion. Recursion is a function that call itself, and as you understand that when you are developing a program, you want to solve a problem. You can break a big problem into smaller problems, and for each problem, you can actually develop a solution using recursion. But recursion can actually substitute repetitive function calls. Like suppose we do a loop. Instead of looping, I'm actually developing a recursive function. Why? Because recursive function actually is a very smart way of divide and conquer algorithms. So take a look at recursive function. We write a function that call itself to solve a problem. And in this case, I must mention that practically this function has a very powerful substitute. You can replace your loop using a recursive function call. It is very well suited to solve a specific type of problem, lead to elegant, simplistic and short code. And the key component of our many assignment is based on recursion. Let us take a look at a non-recursive factorial function. Factorial of number is you are multiplying 1 up to the number itself. For factorial, 5 means 1 multiplied by 2, 3, 4 and 5. Look at this function factorial. In factorial, I'm actually passing a parameter n, and in this function I'm actually initializing total with 1 and ultimately looping 1 up to n and then multiplying each time the value of I with total, and I'm returning the total. So important observation is what? If you take a look at it very carefully, that factorial of 0 is factorial of 1 is 1, factorial of 4 multiplied by 3 multiplied by 2 multiplied by 1, and that means I can say that if I consider factorial 5 multiplied by factorial 4 and so on. That means this is something you realize, that a factorial function is a calling function itself, so I can replace factorial in repetitive using a recursive factorial. You see, take a look at the recursive factorial. In factorial, and then I'm passing n, and then I have a condition. If n is less than equal to 1, then return 1. This is a very important aspects of recursive function. Every recursive function must have a base case. That means a condition where it can exit. Otherwise, you call the function itself. You say return n multiplied by factorial of n minus 1. That means you are calling the same function again. Yeah. So two case. Every recursive function has two cases. One is a base case. That means where you exit, and the second case is a recursive case while you are calling the function itself. So take a look at this recursive handle. It can handle a small part of a task. Look at the stack trace. Recursive stack trace is very important to understand the calls. You call first time passing n is equal to 4, and then the second block you see n becomes 3. Why? Because you said n 4 multiplied by factorial of 4 minus 1 is 3, and then gradually it becomes 4, 3, 2, 1. When it becomes 1, it starts returning. So it's returning the value means 1 multiplied by 2 multiplied by 3 multiplied by 4. That's interesting. So recursive stack trace is very, very important for you to visualize how a recursive function is working. Take a look at this. So recursion and cases, what we have two cases. One is a base case. It's a simple occurrence that can be answered directly. Recursive case, we are calling the function itself. 3 rules of recursion, very important you remember. Every input must have a case, either recursive or base. That means whatever input you give, it must have a base case or a recursive case. There must be a base case. Why? Because otherwise you cannot exit. If there is no base case, your memory will be exhausted because you keep calling and there is no return. The recursive case must make problem simpler, make forward progress with the base case. Take a look at the recursive tracing again. I have a mystery function here. You can understand. We want to see how the output is. It's a very interesting one. It is a mystery function passing an n value, and this n, if it is less than 10, then return n. That means this is my exit case. If that means n has to somehow get smaller, otherwise I cannot compare. Else what I am doing is calculating two values, A and B. What is A? A, I am actually dividing n by 10, and B, I am actually taking a modulus operation by 10. And then again return mystery, that means I am calling the function again with A plus B. Now imagine you are passing 648 in this function. 648, when it comes here, you are actually in the recursive case. So what you calculate? 64 in A and 8 in B. So 64 plus 8 is 72. Now that means you say again call the mystery function with 72. N is now 72. N is not less than 10, so nothing happens here. And then you come into else, you calculate A is 7, B is 2, because it was 72. So 7 plus 2, now mystery 9, less than 10, return 9. That means what is the answer here? Answer is B. So you can understand a recursive tracing is very, very important for you to learn recursive function calling. So recursive stack trace actually I am showing you here. So practically you see that it was 648 on the first call, the second call n became 72, the third call n became 9, and then return 9. That's the answer. So hope you understand and enjoy.